This is Unit 6, Polygons in Motion, Preview Video 6.4, Trapezoids and Kites. Close your eyes, sit tall, ready, inhale, hold your breath. Take a look here, 6.4 trapezoids and kites. In the quad family tree, you have the parallelogram family, which is obviously the largest portion. Definition of a parallelogram, of course, is opposite sides, two sets of opposite sides that are parallel. This lesson is, well, what about quadrilaterals that don't have two sets? What if you only have one set of opposite sides parallel? And that would be a trapezoid, and its descendant an isosceles trapezoid. And what if you have a kite, which does not have opposite sides parallel at all? Instead, it has consecutive congruent sides. So we're going to focus on this side of the quadrilateral family today. So basic definition, take a look here at the trapezoid on the left and the parallelogram on the right. These sentences I am not filling out for you. You are doing this yourself, and I'll be looking to see that you have a sentence. So you're going to write one thing that is the same between these two shapes. What do these two shapes have in common? And then what makes these two shapes different? So pause the video and cite one commonality and one difference between a trapezoid and a kite. Welcome back. Let's take a look here. In a trapezoid, basic definition of a trapezoid is you have one set of parallel lines. One set of parallel lines. Just one, not two. If you had two sets, you would have a parallelogram. So the parallel sides we call the bases. Base does not mean bottom. Base just means the parallel sides. We could rotate a trapezoid this way, parallel sides, non-parallel sides, and these would still be considered the bases. So the word base in trapezoid means parallel sides. The non-parallel sides are called the legs. Now if you take a trapezoid, any trapezoid, and you make the legs equal, then you have an isosceles trapezoid, two equal sides. Now, trapezoids in general, because of the parallel lines, let's come back up here. We're looking at all trapezoids. Go like this, stretch it out, parallel, those are parallel, put the little arrow feathers there. Stretch this out to make a stir stick, also known as a transversal. Because of the parallel sides, the angles on either side of the legs those are consecutive interior, therefore they are supplementary. They add up to 180, those consecutive interior angles. So the angles on either side of the legs, because of the parallel sides, are consecutive interior. Now, when it becomes isosceles, these angles are still consecutive interior, which means they add up to 180. But the base angles, the angles on either side of a base, so the blue angles in this case and the green angles, they're going to be congruent to each other. Just like in an isosceles triangle, two equal sides, two equal angles. That's true of a trapezoid as well. If these sides are congruent, the legs specifically, then the base angles are congruent. You want to mark that and keep that in mind. Now there's another property of trapezoids. So take a look at this trapezoid. Trapezoid here is A, B, C, D trapezoid. So there's your trapezoid. Just trace it. Just physically trace it. We're going to mark E as a midpoint of AD and F as a midpoint of BC. So both of those are midpoints. Now, just trace over this and connect them. Trace over it. That segment there, it's called a median. The segment that connects the midpoints of the legs, and it's specifically the midpoints of leg, is called the median of a trapezoid. It's also called a midseg or midsegment. That median has a very specific property. Let's just bunny hop here. The base AB is 3 units. Let's bunny hop the base of DC. So when you average the bases, we get 6, of course. So the average of AB the base and DC the base is 6. Bunny hop directly E to F. You also see that is 6 units. So here is a very simplistic formula. Is the median, the length of the median is simply the average of the bases. Simply the average of the bases. In formula form is, of course, you add the bases, first base, second base, and you simply divide by 2. Once again, the bases are the parallel sides of a trapezoid. When you use this equation, make sure you use it as medium equals base plus base over 2. Equations have 2 sides with an equal sign. That's very important. So let's take a look here. I'm going to do this page with you and these 2, and then you do the bottom on your own. So your equation is median equals base plus base over 2. So you circle, plug, chug. Median, median, bases are the parallel sides. Please do not be using calculators for things like 12 plus 26. Let's try this next one. Once again, equations have two sides with an equal sign. Medium equals base plus base over 2. Now we circle, plug, chug. Whole number, fraction, put it over 1, cross multiply. So we have 40, and then I'm going to collect like terms. Don't get all happy when you solve for x. There's a super easy way to check this to make sure you're never wrong. So 5 times 9 minus 15. That's 45 minus 15, that's 30. Let's do 2 times 9 is 18 minus 8. Of course, that is 10. Now we take 30 plus 10 divided by 2. 40 divided by 2, 20. Check, check. There's your median. Ready? This one you're going to do on your own. Pause the video and then restart. Welcome back. I hope you're in the habit of writing the equation medium equals base plus base over 2. And in this case, circle, plug, chug, our median is 24. One base was x, the other base was 35. And now you cross multiply. And then you do a check. 13 plus 35, 48 divided by 2, 24. There's your check. Okay, so that's a trapezoid. Let's take a look here at a kite and a rhombus. A kite and a rhombus. Look very carefully. Now, what I want you to do, please, is I simply want you to, 1, physically trace the diagonals. Physically trace the diagonals, please. So trace the diagonal here and the diagonal here. Now on the right-hand side, I'd like you to trace the diagonals of a kite. Trace the outer sides of the rhombus. Trace the outer sides of the kite. Once again, I'm not going to do this for you. I would like you to, in one short sentence, explain in what ways are a kite and a rhombus similar. There's a couple ways. Try to think of a couple. And you're going to write your own sentence there. In what ways are they similar? And then taking a look here, a couple ways. In what ways are they different? You are filling that out on your own. I'm not filling it out for you. Pause the video. And in what ways are they similar? In what ways are they different? Pause. Welcome back. Let's see the next page. What makes a kite a kite? What are some of the unique qualities of a kite? So first off, I'd like you to trace all four sides. And we're going to start with the definition of a kite. The definition of a kite is you have congruent, consecutive sides. Consecutive means next to. So you have two sides that are congruent next to each other. Two sides that are congruent next to each other. Now, these angles, these are going to be called, I'm going to do them in blue, the squiggle angles. These are called the crossbar angles. The crossbar angles, they are congruent, but they're not bisected by that crossbar. They're congruent, but not bisected. In other words, they are not being cut in half by that crossbar. That's very important. They are congruent to each other, but not bisected. Physically sweep the top-bottom angle. These angles are obviously not congruent. You have a larger one here, and then the one down here is smaller. Okay, so these are not the crossbar angles. These are called the vertex angles. These angles, they're not congruent. Okay, they're not congruent. You have a larger and a smaller, but they are bisected. They're not congruent, but they are bisected. In other words, this top angle and bottom angle are bisected or cut in half. So the crossbar angles, let me just recap that. These crossbar angles are congruent, but not bisected. These vertex angles are bisected, but not congruent. Knowing this, I like you to find everything possible in this diagram, including segment lengths, side lengths, and angle measures. Pause the video. Welcome back. Let's see how you did. Let's start with the simple stuff. If this is a kite, if this is 5, this is also 5. Taking a look here, there's a right angle here and here. So in this yellow triangle, if this is 50, this must be 40 degrees because triangles add up to 180. If you have a 90-degree angle here, which you do. Very important. This is a vertex angle, so it's being bisected. So if that's 40, this is 40. And if this is 90, that forces this to be 50. Looking at this yellow triangle, we can solve for the side length by doing Pythagorean theorem. Have two sides, need third side, Pythag. So x, this side length here, equals root 61. Now that's prime, so we're going to take it down to a decimal. And take it to the first decimal place, which is 7.8. Now, because consecutive sides are congruent, this over here must also be root 61 or 7.8. Okay, left side of the triangle, we have found pretty much everything we can. So let's come over here to the right. If this is 5, we have that's 5. And now we're going to find blue squiggle. Call this Y. Of course, you get 13. That's 13. This is 13. Let's take a look at what you know for sure. We know that, be very careful, if you see this as 80, this here is not 80 as well. It is bisected, so let's mark it as bisected, but it is not 80. That's super important. You don't assume that, because this is a kite, not a rhombus. So you're like, I got all the sides. How on earth can I get that angle there? Aha, that's a theta. Now we're using inverse SOHCAHTOA. So that would make 5 from that angle. That would be opposite. This would be adjacent. This would be the hypo, of course. You can use all three. It really doesn't matter here. You can use inverse sine, inverse cosine, or inverse tangent. I'm going to use inverse sine. My opposite is 5. My hypo is 13. That's going to give me my theta. We're going to round angles to the nearest whole degree just for ease. So I'm going to make that 67. That means this is 67 degrees, and because it's being bisected, that's 67 degrees. This orange triangle has to add up to 180, and if this is 90, we simply do 90 minus 67. We get 23. And this angle must be the same as 23 as well. Look at all that information you get just from knowing this is a kite.